In this video, we're going to be doing an engine knock frequency calculation using the MoviChip KSC3 knock sensor controller. If you just want a basic engine knock frequency calculator that gives you a theoretical frequency, I'll put a link in the video description to a web page that will do that calculation for you. So what is the KSC3? The KSC3 is a knock sensor controller. It will give you a visual indication of engine knock using LEDs, and it will also give an electronic indication of engine knock by outputting a 0 to 5 volt signal to an external engine ECU or data logger or whatever you're using. So to start with, we come to the app, we open options, we get all of our settings. The first thing to do is to do baseline calibration off, and this will populate all the stored values in the app. Look, it doesn't matter if you've got anything in there. The process for the knock frequency ID is the same, with the exception of come to load threshold, and maybe we just want to make that close to idle or just above idle. So in this case, I'm just going to put it just above idle, 0.27 volts. We can put signal gain to 1. RPM calibration is not important for this video. And that is basically all we need to do. We just need to make sure that our load threshold is low enough that we will measure a light throttle when we're doing our knock frequency ID. So now we've done that, I've put a very conservative ignition timing map into the engine, so I'm 100% sure that when I'm driving around, the engine's not going to be knocking at all. You can do that however you want. If you're confident that your engines are not going to knock normally, then obviously you don't have to do anything. In this specific case, I've just put an ignition map in there that retards it by 5 degrees everywhere. When I've done that, I just do a couple of pulls at light throttle, just between 2,000 and 3,000 RPM. So that's second gear. I'm just going to click knock frequency on, and I'm just going to go through 2,000 to 3,000 RPM with a light throttle. It's not important what your throttle is. What's most important is that you get as consistent as possible between the runs. So we've got the first run there, the second line, and I'm just going to do that again in second gear. Press on. On will turn green immediately when it's activated. That's 2,000 RPM. I'm just going to pull through it to 3. Click off. That's going to take 3 seconds to populate the next line. So that's 2 runs done. I'll do a couple more. So that's 2,000 RPM again. I'm just going to click on, light throttle through to 3,000 RPM. Click off. So that's 4 pulls there, if you like, of what is a normal volume for each of the frequency segments that the KSC3 is recording. We can see they're all pretty similar. And we're just going to repeat what we've just done, going from 2,000 to 3,000 RPM, but this time the engine should be knocking. So I'm just going to press on, same throttle as before, and that's the engine knocking there. So I'm just going to press off, and I'm just going to repeat this process probably, why not, another 3 times. So we've got 4 pulls, if you like, with conservative ignition timing, and 4 pulls with the advanced ignition timing, and then we'll just do a quick comparison between them. So that's the 4 runs done with the engine knocking. So let's come and have a look at what our KnockID tool is telling us. So for 4.8 to 5.2, they kind of look all similar. 5.6 to 6, they look all similar. 6.4 to 6.8, kind of similar. We've got something going on here at 6.4 to 6.8. If we come to 7.2 to 7.6, we've got 2s, and we've got something at the end here for 7. 8.8 to 8.4 kind of all look similar. 8.8 to 8.9, we've gone from 2 to 4. And we can also see we've gone 2, 4, 3, 3. So it looks like we've got something around there. 9.6 to 10 is sort of 4, which is we had a 4 before, so I don't think that's anything. 11.2 to 11.6 all the same. 12 to 12.4 all the same. 12.8 to 13.2. Well, we had 2s before, then it's gone to 3, 4 and 5. 13.6 to 14, kind of all the same, and 14.4 all basically the same. So what it looks like we've got is the knock frequency being registered around 8.8 to 9.2, and we're going to get some leakage either side of this. So we're going to put, so I would say the knock frequency that we want to measure is going to be sort of 8.4 to 9.6. So then we just come up here, low kilohertz, high kilohertz, and we just enter our low end of the knock frequency and our high end of the knock frequency, and that is it. That may or may not be the same as the theoretical knock frequency for your engine. That is not really the important thing. The important thing is what is the KSC3 measuring as engine knock on your specific setup, how you've got it wired, where you've got the KSC3 located on the engine, etc, etc. This is what's most important. We can use the theoretical engine knock frequency calculator as a guide. So in this specific engine, it's going to tell us it's going to be around 7.2. So we can use that to help us, but ultimately, if the knock frequency ID is saying that I'm measuring knock at these frequencies, then that is the knock frequency that we want to set for our knock frequency window in the KSC3. So that's how you do an engine knock frequency calculation using the knock frequency ID tool that's in the KSC3 app. If you want to learn more about the KSC3 product, I'll put a link to the video description of that product, and also subscribe to the MoviChip YouTube channel. I'll be going through each of the functions that the KSC3 has, so you can see how it's set up and how it works. Look after yourselves, and I'll see you again in the next video.